Hi guys, welcome back again to Math 100. Today we are doing section 12.2. This is the second section of chapter 12, second of three sections we're planning to do. Last time we talked about permutations, and today we're talking about combinations. Combinations, big topic for today. Basically tell you how many ways you can choose a smaller group from a larger group. The number of ways that you can do that. And by the time we're done today, you'll know what I'm talking about. So what is a combination? You notice the definition very similar to permutation. A combination, first of all, shares the same number one as a permutation, that you don't repeat items. No item is appearing more than once. And then the second part, which is different from permutation, is that order does not matter. So remember in permutations, what does word permutation even mean? It means to rearrange something, right? Permute means to rearrange. A permutation is a rearrangement. So that differs from combination. Combination, the order is not important, so you don't care about a different arrangement. That means something like 1, 2, 3 or 3, 2, 1, we consider them the same if we're talking about a combination. You just have the same three numbers. Okay, so let's talk about the English here. The word combination, combination, probably comes from the fact that it's a combination of items, a combination of the items from a group of items. So let's start with some basic questions just to get a feel for what a combination is. Now, I always recommend pause the video, see if you can try this out on your own first. Numbers 1, 2, 3, 4. And then once you've given it a crack, you think you have it all down, then confirm with my video and see if you have the same answers. So number one, how many ways can you choose one number from the numbers 1, 2, and 3? Okay, well, you could choose 1, or you could choose 2, or you could choose 3. So the answer would be 3 ways. Yeah? Okay, what about number 2? How many ways can you choose two numbers from the numbers 1, 2, or 3? Well, I could choose 1 and 2. I could choose 1 and 3. Or I could choose 2 and 3. Excuse me. You notice last time with permutations, we considered something like 2, 1 to be different, right? And 3, 1 to be different from 1, 3, and 3, 2 to be different from 2, 3. But in the case of combinations, those are not different. Those are the same because I don't care about the order. I just care that I have those two numbers. So again, I only have three different ways. Those are the three. 1 and 2, 1 and 3, or 2 and 3. Number 3, how many ways can I choose 3 numbers? Well, if I've got 3 numbers, there's only one way to do that. I got to choose all 3 of them, right? 1, 2, and 3. So that's one way. And then number 4, how many ways can you choose 0 numbers? Well, this is sort of like a vacuous question. And the answer is just I don't choose any. So there's always one way to do that. You'll notice though, if you're paying close attention, you'll notice there's a connection here between something that we've seen a while back with set theory. And in set theory, remember, if I have things like 1, 2, and 3, if that's my set, I could choose a subset that has 0 things in it, which would be the empty set, right? I could choose the set that has all 3 things in it, which would be the set itself. Or I could choose things that have 2 of the elements or 1 element, right? And that encompasses all the different subset possibilities. So if I was to add up all together, I get the number of possible subsets. That's kind of a side note, but it's a connection to something we've seen before. Okay, the first 4 questions were just to get you a feel for what the heck is a combination. So now that we sort of have an idea of what it is, let's talk about the formula for how to calculate these things. Okay, but first, let's recall the formula for permutations. This is something we did last class, right? We had NPR, that's n factorial over n minus r factorial. That was the formula. If you remember, if you reduce that, or not reduce it, if you rewrite that a different way, that's just saying n times n minus 1 times n minus 2 all the way down to n minus r plus 1, and that gives you r items, right? So r things that you're multiplying together. Oops. And where does that come from? It comes from, okay, you have r spots. If you have n items to choose from, the first spot has n, and then n minus 1 and so forth, right? And so that's where this formula popped out. Okay, so let's think about that formula. Keep that in the back of our head, back of our mind. And then we're going to talk about the new formula for today, which is the combination formula. So what is it? Okay, well, first of all, what does it tell you? It tells you if you want to take r items from a group of n items, that part should sound familiar, right? Just like with permutations, we're taking r items from n items. But this time, if I'm counting the number of combinations, here's what pops out. First of all, notation, NCR instead of P, because C for combination, right? P was for permutation, C is for combination. Excuse me. And the formula, notice, looks very similar. The top is the same, n factorial, right? The bottom is n minus r factorial, just like it was with permutations. And then the only difference is I get this additional r factorial on the bottom that I'm dividing by. Okay, so that's the only difference. How do we read it? We read it as n choose r, and that's because it's the number of ways to choose r items from a group of n items. That's what it represents. I wrote that big because that's the best way to think about this, I think. It's like, what is a combination? I have a bunch of stuff. How many ways can I pick a smaller set from that? How many ways can I pick 2 items from 3 items? Or let's say I have 10 things. How many ways can I choose, I don't know, whatever number you want to choose. 4 items from those 10 things. Or 5, or whatever it is. But the number that you're choosing has got to be smaller because you're choosing from the bigger set, right? Okay, now I started by reminding us of the permutation formula for a reason, because I wanted us to note that similarity here, right? This is the same thing as a permutation formula, except for this little r factorial. What does that r factorial represent? Well, if you think about it, this r factorial, that's something we learned about from our last class in permutations, right? This is the number of ways to permute or rearrange, let's say permute because we learned that word last time, yeah? To permute our things. So why are we dividing by that? Well, the reason for dividing by that is because if you think back to, like, let's look at this example from number 2. So if I was to list all the permutations, I'll list all the different permutations below. They would look something like this, right? Well, in a case of combinations, I want to divide by how many ways I could rearrange those choices that I've chosen, the 1 and the 2, because I'm going to count those all as just 1. So this action of dividing by the r factorial, that just essentially just reduces this count to get rid of the number of ways to rearrange that smaller group. So now I'm just counting that as 3 different ways, like I should with the combination, right? So what are you doing? You're dividing by the number of ways to rearrange those smaller groups of things, because you're not caring about the order that those things come in, just that I chose those smaller group of items. So take a moment just to let that sink in, let the idea sink into your head. Yeah, pause it even if you need to, just pause it to think about it more. Okay, well, long story short though, guys, what do you really need to know? And I'm going to stop this video pretty soon. The main thing that you need to know is, what does this whole thing represent? N choose R, NCR, represents the number of ways to choose R items from a group of N items. Okay, last thing before I finish this video, there is an alternate notation for NCR. Sometimes you'll see it like this, but it means the exact same thing. Just depends on which textbook you're using. I think our textbook actually will sometimes use both, just because these are the 2 most common notations for combinations. So this is still read N choose R. It looks kind of like a fraction, but you notice there's no fraction bar in the middle, right? There's nothing in the middle. Just a number on the top, number on the bottom, inside of a big parentheses. And that's also equivalent to NCR, like that. All right, guys, I'm going to cut this video off, and then we'll jump into the questions.